Okay, hi everyone. So I'm going to start sessions on today. We are going to discuss couple of algorithms on linked list. Okay, so just want to start the discussion. So who all knows about the linked list? So um, I think Tarun, he joined couple of folks. He is from Hyderabad. Tarun, and what about you, Aditya? Where are you from? Aditya, right? Your name? Hello, can you guys hear me? Yeah, I think is that Aditya? He said I can't hear. Maybe he's muted. So, but anyway, so I think we have good understanding of linked list. Otherwise, I can kickstart what is linked list and how it works. Asia, do you have understanding of linked list and how it works? Okay, nice. Asia, you said yes. So the basic I will use this just linking alphabets. This is the app I built a couple of years ago in Windows Store, so I'm just used for explaining purpose. So everyone knows that linked list has two things, right? Every node has two things. One is data. This is data part, and this is the next address, which is address of the next node, right? And this is data, and this is the address of the next node. So and the last node doesn't have any address but which has data here. So this is the way linked list works. So linked list, the advantage of linked list compared to arrays, we all know the linked list is expandable, so there is no limit. Whereas arrays, when we are declaring arrays, you have to say what is the size of the array you want, right? So the advantage linked list provides is you can add up, you can keep on adding the nodes anytime, and also dynamically it can increase, and also you can remove any node if you want. So the arrays, that's the main problem with the arrays, right? If you declare array with let's say 100 elements and you have a couple of elements, if you want to delete one element, you have to shuffle rest of the elements into the that position. Otherwise this memory is wasted, right? So that's the main. And another difference between array and linked list, this is a contiguous array memory locations in the memory, but in case of linked list it will be random, right? So one first node will be somewhere in the memory, and second node will be another somewhere in the memory, and third node will be somewhere in memory. So it's like randomly assigned, and so this is how it was connected, right? So each node has the address of the next node. It looks like Aditya, he disconnected, but that's fine. So we'll continue. So that's the basic difference here. So now there will be different algorithms on linked list. Like people simply ask, "Hey, write an algorithm just to insert a node at the beginning, or insert a node at the end, or reverse the linked list." Or there are different. There will be tons of algorithms and linked lists. I really like the linked list data structure because it enables us more discussions, right? I like to ask any algorithm which enables to discuss more with the candidate in interview. So either arrays or linked list or strings, those are the good algorithms where we can have good discussion. Okay. So um, coming to the algorithm that we are going to discuss today, of course, we discussed a couple of algorithms before. These are the things I discussed before. There is the recordings also available. Like write a basic logic for adding a new node, deleting a node, reverse the linked list. Okay, print the linked list items in reverse order, and all these things. And I think we also discussed about a linked list, a stack implementation using a linked list, a stack. So anyone can anyone explain the stack, how it works? Sure, Aditya, do you have understanding of the stack? You can unmute and discuss. Asia, can you speak? I can't hear you. Okay, you're joining in a different laptop, it looks like. Yeah, go ahead. We still can't hear you. Did you join through laptop? Okay, Aditya, can you try to speak up and see if you can share? Aditya, did you join through laptop or phone?
Yeah, I'm sorry for that. Like, actually, the power was cut from my
Yeah,
side.
I can hear you. I can hear you. Go ahead.
Yeah, like, I have no questions right now.
So, what is the? Can you explain a little bit of Stack? How it works? Stack.
Stack works on LIFO principle, last in first out. Um,
Okay.
like once we just add, it forms like a bucket form of data structure where we just put in the elements and we can remove the elements from the top of it only. There certain functions are there, methods defined in stack. Some elements like pushback, pop,
Hmm.
top, and these kind of methods are there.
Very good. So, have you tried implementing LIFO that the stack is using a linked list?
Through array I have done, not linked list part. I have not completed it. I
That's
was
good.
a
So
bit
we yeah,
confused when
that's
it.
one algorithm we discussed before, but you can try it out. Basically, you can last in first out, right? You can keep adding nodes at the beginning, and you can add node. You can remove the nodes on pop. You can just remove the nodes from the beginning. It's just like that's how it is, right? You can just pop it because you have only access to the head,
Hmm.
right? So so
Yeah, exactly.
so push means you push an element at the beginning of the linked list, and pop means you remove the element from the beginning of the linked list. So and the top, even the top element, that's a first element of the linked list. So it's very intuitive to implement. Yeah. Okay. So that's the linked list. We discussed about it, and we also discussed about other like finding a loop in the linked list. Let's say some linked list has a loops. Okay. So this is also very important algorithm. So let's say there is a loop in the linked list, right? So something like this. So we need to find whether a given linked list has a loop, if it should return true or false. And if you return true, like if there is a loop, and what is the node which is intersection or the starting of the loop, this is the starting of the loop, right? Very important. It is part of that book, the cracking the coding interview book. So please ready, or please read that algorithm, and also or watch my video. I will send the recordings. So that is also very important algorithm. So coming to the today's algorithm, we want to discuss, we covered until here in the previous algorithms. So let's implement a queue using linked list. That is the motto of this today's session: how to create a queue data structure using a linked list. And who want to explain the queue data structure, how it works? Just start with a simple discussion of the queue. Anyone explain queue? Of course, Asia, I can understand you're in work and you can't talk, but I'm asking either Tarun or Aditya. Queue data structure.
Yeah, just the reverse of it, like FIFO principle. We just add on elements and we can remove the elements. The last added, the first added will be removed first.
First in, first out, right?
Yeah, exactly.
Okay,
Exactly.
that's good. So, and what are the operations on linked list? What are the different operations in the stack? We call pop and push, right? So, what are the different operations that we do in the link in the queue? Are you following? So, what are the different operations? It is the queue, right? Here is the front of the queue, and here is the rear of the queue. Okay. So what are the different operations in linked list, in the queue? Anyone can guess? Tarun? Yeah, go ahead. Tarun, I can't hear you. Aditya, can you guys hear me?
Yeah, yeah, yeah.
Yeah, so what is the different operations in queue?
At this time, I am not exact, like somewhat related to push and pop only. What is
That's
it
what we
different?
call NQ, right? NQ. Asia,
Oh
you
yeah, NQ and
can
DQ.
type
Yeah,
the
yeah.
answers in the chat.
Okay.
So NQ and DQ, right? Do you know that? NQ is basically adding, just like push, and the DQ means pop, just like removing element from the queue. Okay, NQ, DQ. Okay, so and also we can have other things like count or yeah, count is also there. So you can also write we implement the count. These are the main things. But where to implement, like where the main difference here is NQ. NQ means adding. Adding will always done at the rear. That means let's say this is the queue and here is the, let's say you are at the queue and the movie theater. This is a movie theater and here is a counter where they are giving the tickets. Okay, right? So the people will join from the rear. So the NQ, whenever you want to include element, it has to be joined at the rear. You can't join in the middle of the queue or the front of the queue, right? So they will always go to the back and join. That's a NQ. The insertion of the elements happens at the rear and removing happens at the front. Because let's say you got the ticket, right? This element need to be removed from the queue. This guy got the ticket, this will be removed. So the removal happens from the front and insertion happens at the rear. That's the main difference between queue and stack, right? So now how to implement this in linker list. So I just discussed, I just drew a array. Now how to do this in a linker list, right? So here is the different linker list nodes, and so this is address points to this one, this one, this one, and this one is the last element. And here is a head node. Head node points to this first node. So now how to do this, right? So let's say this is the rear of the queue and this is the front of the queue. Okay. So now if you want to insert a new element, I want to insert a new element. Let's say a new person came and he want to be in the line. So where do you want to insert? You have to insert at the end, right? Isn't it? So let's say these are the elements A, B, C, D, E. Okay. And you want to insert, there is an element called F. So we want to insert F after E. So how do you do that? So header always have the pointer which is pointed to the first element. So Aditya, can you explain, like do you know how to insert an element at the end?
Traverse a while loop
Mm-hmm.
till the head becomes null. The head is the head, and next to the head is returned to the head, and then we can traverse in that way.
Yes, yes. Basically, you need to have a pointer that points all the way to the last node. Let's say this is the pointer. The pointer, you start with the head and you navigate. Is it the last element? 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 You will have that condition, and one until you find the last element, right? Hey, finally you found the last element. Then, because the last element, how to find the last element? The next pointer should be null. So for any of these elements A, B, C, D, the next pointer is not null, but the last element, the next pointer is null. That is the indication that this is the last element, right? Once you find the last element, what you do? You just connect that to the new node that you created. So you simply connect this node, right? The last node back to this new node. That way, you are adding an element at the end, isn't it? So now that's a NQ operation. You did that NQ operation. How about DQ? DQ means which element? Let's say if I just call DQ, this is the entire thing is a Q. So now I say Q dot DQ. So which element we have to remove?
E.
A. Very good. So we need to remove the first element. So how to remove the first element? Is it very easy or difficult? It's very easy, right? Because head is already pointed to the first element. Simply head equal to head dot next. If head pointed to next element, then we are done. That this element is got removed by garbage collector. So removal DQ is very easy. NQ is little bit of tough because you have to navigate. You have to have a pointer that navigates from beginning to the end every time. Okay, so we can also do a simple optimization. Basically what we need to do is, rather than having like, we need to implement this queue. Of course linked list have only have head, we always know that. So in order to easily identify, in order to, we don't want to navigate every time from the beginning to the end. Let's say we want to keep increasing the elements or inserting the elements. That can be done easily by having another pointer, head and tail pointer or end pointer. Let's say e is another pointer that always points to the last element. Let's say the e pointed to this last element. Right now we have a b c d e f, and head h pointed to first element, e pointed to last element. Now, if I say NQ, DQ dot NQ of, let's say K, I want to insert an element called K. What you do? You no need to navigate from the head. Simply E dot next equal to that element K. Automatically, the E pointed to the F, and this will be pointed to the next new element, isn't it? You guys understood the concept here? Give a thumbs up or something, or if you have any questions, speak out. Otherwise, I don't know whether you understood or not. Okay, Aditya got yes. Tarun, are you following so far? We can't hear you from there. Maybe some.
Yes, Suresh.
Awesome, awesome. And Asia, is it clear? You can put it in the chat. You joined again, or Aditya joined through different computer? It looks like. Asia, is it clear? Okay. I will go ahead. So basically, by having two pointers, we can easily do the NQ and DQ operations. Very easy, right? And of course, we can also maintain a counter that will count the elements every time. So let's say you are increasing, let's say you are adding an element K. Once you add an element, you increase the counter plus plus. And if you remove, let's say you removed A, you can decrease counter minus minus. You can remove that counter every time you remove the element. So NQ will increase the counter, DQ will decrease the counter. That way, at any point of time, if I say Q dot count, it will tell you how many elements in the queue. Okay, is it clear to everyone? It's a basic algorithm. So we need to implement NQ, DQ, and a count. Okay, so if everyone is clear, I can show the coding of this algorithm. Very easy. So once you understand this whole logic, we can definitely do this. So one thing we need to be very careful is, let's say in the beginning, let's say, as I said, let's say start and end. For simplicity purpose, start and end. Okay, start and end both are null because there is no elements yet. Okay, now I call q dot nq. If I call nq of number, let's say number 2, I added an element called number 2. So what you're going to do is, these are the steps. First you need to create an element, a node, linked list node, and put the data 2 here. And now it is a single element, there is no elements, right? You next pointer is null. And then, since there are no elements, both start pointed to the same element and end also point to the same element, isn't it? That's the first step. Now I am going to call another nq of 5. I'm adding one more element called 5. What you do? First you will check, is the linked list empty or not. Of course we will counter will be incremented. You can maintain the counter. You can simply say, is it count equal to 0 0? If count is 0, That means, so let's say counter here, counter equal to 0, or now which is counter is 1, right? Counter is not 0, there is one element. So counter is 1, that means we have some elements, there is one element in the linked list. Now what I said, in order to enqueue, you have to enqueue the element at the end. That means you create an element with value 5, and we need to update which pointer, start pointer or end pointer. Anyone can guess?
End pointer.
End pointer. So we know that if counter is 1, that means one element already there, and we already know that the end pointer is already pointed to the last element. Simply end dot next equal to new element. Let's say this is new element, new element. So what we do is we simply update end dot next equal to new element, and end equal to that new element, so that next time when you inserting, it will be inserted after 5. So in this situation, you don't need to update the start and the end start, because start is always pointed to the start element. Don't update start at this element. Now let's say I am doing dq. Dq means I am deleting an element. So now again, like, of course, after adding 5, the counter will be 2. So now we will check, is counter 0 or not? No, it's not 0. Counter is 2. There are two elements. Now we know how to, this is the tricky part. No, it's not tricky part. So if I say dq, right, which element we need to remove?
First element.
First element, right? So if dq means we need to update which pointer? The start pointer. We need to update the start pointer. Yeah. Hey Devanand, welcome. Welcome to the class.
Hi, Suresh.
Very good.
Hi, Suresh. Yeah.
Yeah, Devanand is my friend, and he joined couple of last two classes. So right now, Devanand, we are discussing about an algorithm called implement a queue data structure using linked lists. Okay,
Okay.
so I'm
Okay.
just explaining how to do this. So after this program, then we'll talk about you and your interview experience and all. Okay.
Okay. Yeah.
So let me continue the session. So basically, a queue contains, you know this, right? Queue is like first in, first out. Whoever is the in the first in the queue, they will be the one we need to remove, right? So
Okay.
we, so the queue is always like this. Just giving a brief history. So this is the front of the queue. This is the end of the queue, right? And here, let's say it's a movie theater and movie ticket counter, right? So whoever gets the ticket in the front, they will be removed from the queue, right? And the new person always joins at the end of the queue, isn't it? Devanand, you have good like a basic understanding of the queue, right?
Right. Right. Right, Suresh.
So how to implement this queue mechanism in using a linked list? That's what we are discussing here. So this is an array. I just showed as an array. So instead of array, let's try to implement as a linked list. Okay. So in the linked list, what we are going to do is we are going to maintain two pointers, because insertion happens at the and deletion happens at the beginning. Okay. So here I point, like I created two pointers, start and end. Okay, this is the start. So here is the start and here is the end pointer. Start pointer always starts with the start element, and end pointer points to the last element. Okay. Right now, the count is 2. That means there are two elements. So we enqueued 2, we enqueued 5. Now we are dequeuing an element from the queue. Dequeuing always happens at the front. So because we need to remove it as a queue, right? Queue always removing at the front and insertion at the back. So in order to remove number 2, we need to update the start pointer. Very simple. Start dot next equal to start dot next, right? So if you update start equal to start dot next, that means it will point to this element, isn't it? So start dot next is here, and that's what we do. Start equal to start dot next. That means start will point to this element, and this element, the first element, will be climbed by the garbage collector. We no need to worry about it. Okay. So now at this point, we have to decrement counter. Counter becomes 1, right? So now I'm doing one more thing like DQ, one more DQ. If I say one more DQ, what will happen? If you do the same thing, start equal to start dot next. That means start dot next is null. So start becomes null. At the same time, counter becomes 0. Now at the same time, like if the counter becomes 0, we need to make sure we have to update the end as well. Otherwise, what happens is, end is still pointed to 5. That is the problem, because you removed 5 too, right? If you say DQ first time, 2 will be removed. If you say DQ second time, 5 should also remove, and both the pointers need to reset to null. That is very important thing while writing the code, because we are maintaining 2 pointers, and make sure 2 pointers are updated at the correct times. Okay, if there are multiple elements, that's fine, you can just update start, you can update queue and at the correct times. But if there are no elements, we have to update both the pointers. That is very important thing in the algorithm. Otherwise the algorithm is pretty simple. Okay, I'm going to show the code. If everybody is understood the algorithm, I'm going to show the code, and I will share this link as well. Here is the algorithm. So queue linker list implementation, you can also go through this Geek for Geeks and understand. So I think I opened somewhere here, maybe here. My system is a little slow here. Yeah, so you can have a lot of implementations in Geek for Geeks. You can go through that. um, why this it's not loading the diagram? I want to show the diagram. If it loads queue implementation in Java, let's open the other link. Okay, this one also, yeah, see this is what I'm talking about. Queue is here, data reference to the next node, the friend element removed from this, and rare element added to this end. So by maintaining 2 pointers, we can implement this queue data structure. So these are the things: insert, remove, peak. Of course, this he just said like insert, remove, peak, but usually queue has methods called enqueue, dequeue, and count. Okay, or top, whatever. So now it's not loading, but let me open my code and show you. Okay, so I use C sharp. This is the language I used most in my career, so I like C sharp. But since it is a basic algorithms, it doesn't matter, you can easily understand. It's a little bit of change compared to C sharp and Java, or in Node.js or whatever. Not Node.js, yeah, JavaScript. Very small changes to the syntax, but it's almost the same thing, right? So let me know if you have any questions. I'm just showing the code here. So I created a node class. So basically we need to create a node class, because node class is node, it represents the one element in the linker list, right? Which has two things. Main thing is data, and the next pointer is again node. So it's an address of the next node, right? This is the basic structure of the node. And I think this yeah, linker list has only two things. And here is the constructor. We are, let's say I want to put 5, I want to put 4. This is the, we'll just pass that, and we will create a node with that data. And also if you are saying add links, let's say you are providing another node, I simply update the next pointer to that node. Okay, this is like linking two nodes. You are passing another node here, and this node instance will be connected to that next node. Okay, and here is the main implementation. A class to represents a queue. The queue, the front stores the first node of the linked list, and rear stores the last node of the linked list. So I just called front and rear as it showed in the other page. So here is the queue. So queue, this is the constructor. Whenever you create this queue class, we are simply setting rear and front to null. This is initializing initial situation, right? Next one is enqueue, method to add a key, an element to the queue. So here is the integer is the key. Let's say you are not saying like add a node, you're just saying add a node with value 5, add a node with value 6, or whatever the integer value. We are talking about data in integers. So simply in the entire method need to take care. It has to create a node and it has to link properly. Everything we have to do on ourselves. So here is the simply I'm creating a temporary node. It's a new node with the value key. Okay, and this is the situation. If the queue is empty, then new node is front and rear both. As I said, right, this is a, if the queue is empty, there are no elements, then what we need to do, we need to make sure both front and rear pointed to the exact node, the same node which we just created. So simply saying front equal to rear equal to temp, that means both front and rear pointed to the same new node, and then return. We are done. No need to do anything. If this is the case, like if you are adding a first element, you no need to do anything. Just point front and rear to the new element. Okay, return. If not, what happens is it comes here. If rear not equal to null. So in this algorithm, I did not maintain any count. So that's fine. So we are not providing any count of the queue. Okay. I'm just always basing what is the value of the rear. So now here rear is not null. That means here is the line number 42 is saying it is not null. So it will come to the line number 47 and then add new node at the end of the queue and change the rear. Simply this dot rear dot next equal to temp. So we are connecting the last element to the this temporary node we created, and we also updating the rear, because otherwise if you don't update rear, what happens is the new node will be replaced by another node. So you have to update the rear pointer. So now rear equal to temp. Is it clear, everybody? Thank you. Just give a thumbs up or ask any questions before we going to the next method. Devanand or Aditya, is it clear? Or Tarun, Asia? I don't see any response. Devanand, can you hear me? Aditya, is it okay or any questions? I want to make sure we understood the whole concept. Just want to get some feedback before going further. Tarun, can you hear me?
Yes, Suresh. Yeah.
Okay, yeah, that's good. Yeah, I want to make it like a conversation, so please speak up and
Yes,
give
Suresh.
feedbacks.
It's
Yeah,
clear. You can.
so that I can easily understand where are we at. Okay, so now DQ method. Okay, this is the method. Okay, now I got some feedback from someone. Thumbs up. Thank you.
Suresh, your voice is breaking. Maybe my side network is slow, or I don't know.
I don't know. Tarun, is my voice
Clear,
breaking?
like
Huh?
your voice is.
Is it clear, Tarun? Okay. I think Aditya also again just joined. Tarun, is it clear my voice? I think maybe Devanand, you have some network issues because it's showing green for me. Yeah, it's showing as green. So Tarun, is it still clear my voice? Okay, I will take it as yes, and I will further go ahead. So next one is DQ. Okay, method to remove a key from the queue. I want to DQ. It's same thing as I said. If the queue is empty, return null. So if people are saying, "Hey, remove," but there are no elements, this is the point to check. Okay, if the front is if the front is null, then return. If the front is null, you no need to do anything. You no need to remove anything. This is another condition, right? So otherwise, if it comes to the line number 60, that means front is not null. There is an element in the front that we need to remove, right? So what we need to do is move front one node ahead. Simply move the front. So temp equal to this dot front. This dot front is like temporary. We are putting in a temporary node, and then front equal to front dot next. Simply front equal to front dot next. So if by any chance there are no other elements, what will happen? Let's say only one element, then front becomes null, right? That is what we are checking in the line number 67. If front becomes null, then change rear also to be null, because if front what have when that front becomes null, if only one element is there. If only one element is there, you already updated front. Now front becomes null. That means there are no elements in the queue. We need to update rear as well. Rear equal to null. Okay. If not, we no need to update the rear. If let's say you have five elements, you removed only first element, then don't update rear. We should not update rear. That's why we need to check. If the front becomes null, then only set the rear also null. Okay, so dq is always about front and nq is always about rear. So that is the difference. So we have to have all the conditions of rear in the nq scenario. Okay, and in the dq we always take care about the front. So that's the algorithm, very simple. I hope we understood every line of the algorithm. And here is the main algorithm which will run it. So basically I am creating a queue the instance of the queue class, and I'm enqueuing 10. I enqueued q dot enqueue 10, q dot enqueue 20. So I'm just printing q front, q dot front dot data, q rear, q dot rear dot data. What will happen? Front becomes 10 and rear becomes 20, right? Then I'm dequeuing. Let's see. Let's run this algorithm and show you. Hey, I'm seeing new person. Hey, Abhi. Welcome to the session. We are discussing about the queue implementation using linked list. Okay, we are almost end of this particular algorithm. I am executing the element the main algorithm and show how the NQ and DQ is running. Okay, so I'm recording session. If you want, you can definitely watch the recording of this session, so we can now we can discuss about those as well. So front of the queue, as I said, if you add front 10 and then 20, the front becomes 10 and the rear becomes 20. Then you dq two elements. Dq this element, the first dq will remove 10, second dq will remove 20, and then you add it again nq 30, 40, 50, 60, right? And you removed one dq. Then what happens? You added 30, 40, 60, 50, and 60, and 30, the person with 30 got a ticket, so he removed from the queue. Let's say it's a queue in the movie theater, right? Now we have four elements. Once more about NQ and DQ. Okay, he's asking about Abhi is asking about what is NQ and DQ. So basically, NQ means inserting an element, DQ means removing an element from the queue. So I hope you know the basic operations of the queue. So we implemented the queue data structure. Basically, this is a tricky question. Creating one data structure using another data structure. This is the algorithm that may come in the interviews. People ask, hey, implement a queue data structure using a linked list, because queue is something which is a little bit different than arrays and stacks, and it's a different unique data structure, right? Queue have a capability where you insert the elements at the front, no, insert the elements at the rear and remove the elements at the front. Okay, so we just discussed about it, Abhi. So this is like if you are at the movie theater, let's say this is a ticket counter, the people will join from the rear, right? And then the people who got the ticket, they will be removed from the queue. This is the entire queue. So so the person who got the ticket, they will be removed. So this is the front of the queue and this is the rear of the queue. Okay, we have to implement this mechanism using linked list. So in order to do that, we maintain two pointers like front, and you can say start and end, or front and rear. So we maintain two pointers, and we are keep on updating those two pointers. Okay, that's the algorithm, and we are running the algorithm and showing here. So here is the node class, and here is the enqueue. Here is the enqueue method. Okay, so the basic algorithms here, we are creating a new node and we are checking if the queue is empty, then put rear and front points to the same element, and then if not, rear becomes rear dot next equal to temp, and rear update the rear, because you are adding element at the rear or rear, what we call, I don't know, the pronunciation is different. So rear, we add element at the end, so that's why we are simply saying rear dot next equal to temp, and we have to update rear so that rear points to the last element. If in case of DQ, we need to DQ element from the front. The people who got the ticket, they will be removed, right? So that is what we are checking here. If the front is null, there are no elements to remove. The queue is empty. You're asking me to remove where there is no elements. So it's simply written, you no need to do anything. Otherwise, take the value into the temp and front equal to front dot next. And if by any chance the front becomes null, that means there are no more elements in the queue, then you also need to update rear equal to null. That's it, very simple. And never miss these boundary conditions. Without these boundary conditions, like 57, line number 57 is very important. Okay, and similarly the other thing, the condition of the rear, this is also very important. Otherwise the algorithm may enter into the error cases. So now what I did in the main algorithm is, coming back to the main, I added two people, like two people in the line, 10 and 20. They both got the tickets. So 10 will be removed and 20 will be removed in the line number 82. Now there are four people joined in the queue, 30, 40, 50, 60. Now, now in the line number 87, we dequeued one element. That means,
Uh, Hello.
yeah, go ahead. Go ahead, Habi. Do you have a question? Yeah, Abhi, go ahead. Do you have a question? I can't hear you properly if you're talking. Did you join through phone or?
Sir, I have a question, sir. I have a question.
Yeah, please go ahead. Yeah, what is the question?
Audible?
I think I can't. I did not get the question. Can you repeat? Okay, Hindi. I can speak only English or Telugu. I don't know Hindi. Or if someone knows Hindi, you can. Anyone can translate. Yeah, go ahead. You can unmute and try, or you can type the question in the chat. Okay. In the meantime, I will continue. So line number 87, you're dequeuing. Basically, the first person in the queue got the ticket, right? Who is the first person in the queue? Now 30. 30 got the ticket. And then who is in the front? 40 and 60 in the end. So look at the output, right? Is it clear to everyone? Except maybe Dabi has some question, but about what about Tarun, Asia, and Aditya? In the queue for adding elements, we use NQ. Yes, that's right. Abhi, you're right. In the queue, adding elements NQ and deleting elements DQ. So if you guys understood, give a thumbs up. And elements add on start or end of the queue. Elements will be added at the start of the queue. Sorry, end of the queue. So as I said, so this is the, like in stack, everything happens on top. Stack, yeah, stack is happens everything at the top, but in queue, let's say this is the front of the queue or start of the queue, and this is the rear of the queue or end of the queue. So the insertions happens at the end, and removal happens at the front or start. Just think of as a queue in the airlines or airport, or queue in the cinema movie theater, everywhere. Queue is very simple to understand, like it's a regular thing that we see everywhere. Okay, the new people cannot insert in anywhere. You will get a big fight, right? Push or pop or top, every operation done on top of the stack. I know. So we are not talking about the stack. Stack is something like this. You will put on top of each other, like it's a disk of plates, or disk like a set of books, in a big shelf. You can only take from the top. So you can insert at the top and remove from the top. But the queue is different. Queue is like a front of the queue and a rear of the queue. There are two things, and we have to manage those two things. That's why we are maintaining two pointers. Is it clear, Tarun, Asia, and Aditya? Give a thumbs up if it is clear. I don't see any response. Is it clear? Okay, Tarun, Asia, I hope you understood. Abhi, is it clear now? I want to make sure you understood the algorithm. Okay, I don't see any response there, but I hope you understood. Okay, that's about the first question. I can jump into the next one if you have any question. If you don't have any questions, otherwise we can also stop here. We already spent more than 1 hour. So the next question is, maybe we can discuss next week, is creating a copy of immutable list. So given a list, we have to create copy of the list. We can discuss that. Um, Anyone have any other questions? Abhi, Tarun? You can type in the chat as well. Would you like to speak? Like to speak? Yeah, go ahead, Taran. I think you're. Please go ahead. Speak up. That's good. I got a thumbs up from Aditya and Abhi. Thank you for that. I need responses, so that otherwise I'm just talking to a wall. If you if there is no responses, it will be tough for me to understand. That's great. Go ahead, Taran. I think you raised your hand. Please unmute and speak. I think Tarun, you have a question. It looks like, but yeah, go ahead and speak up. So Abhi, are you part of the any groups? I'm part. I have a Discord group here, where I'm not sure whether you. I think, is it Abir? Is it different than this one? I saw Abir here, but Abhay, you are different. Abhay, it looks like your name is different. Um, Reverse string using recursion. Yeah, that is a good algorithm. But I'm asking, are you part of the Discord? If you are part of the Discord, I will add to the group, so you can join every week. That's great. Go ahead, Tarun. I think you have a question, but you can't speak up. We have issues, network issues. Tarun. Okay, it looks like you have some issues. Yeah, that's the problem. Like we should have a good network connection to have the conversation. That's the main problem people are facing. So I have pending. What are the? I just got a friend request. I'm trying to accept. But anyway, so here is the here we have a couple of groups here. So I usually send the invite and the details about the class. It's the same time every day, every Saturday 8:30 ist. So join the same link and be part of this community. We can share algorithms and learn each other. Okay. Hey Tarun, you joined again. Can you speak up now? I don't know. Maybe issue with this with this Jitsi. I don't know, but the main reason I'm using Jitsi is a free tool, and Jitsi provides recording as well, free recording. There is a glitch in the app. Yeah, there are sometimes glitches, but it's open source and it will be helpful sometimes. Like we can record and do it. Why not? Google Meet has a problem, man. It has only 1 hour limit. So Google Meet has 1 hour limit. That's why we can't extend. So right now we discussed more than 1.5 hour. Look at that. Like the recording is like 130 minutes. So can you please share Discord link? I can definitely. Discord link here. You can just simply search for Mentor Suresh. I can also. What is Discord? Okay, Discord is just like WhatsApp or Google Meet, something. It's an open source mechanism of connecting people. So just like you can have groups, you can chat with each other. They also provides video and audio, but the problem is the recording. The recording is not there. The only reason I'm using this Jitsi is free recording. Okay, so let me put the Discord link here. So install Discord, Discord, discord.com, and search for my name, Mentor Suresh. You can find me and send a friend request. And let me also send this algorithm link. I will send in the Discord anyway, but I'm going to share this algorithm as well. And please bookmark this algorithm, and you can practice. You can copy and convert into different languages. That is another thing of this online GDB is yeah, this is a good site where you can convert from one language to another language. Let's see if that converts into your favorite language, Java or other things, whatever it is. And you can also try and in PHP, Kotlin. There are a lot of languages available. So you can also try converting and run in your language of your favorite. Yeah, go ahead, Himanshu. Is that you just joined? Welcome, Himanshu. Yeah, please go ahead. What is your question? You can speak up. You can unmute and speak up. Can any one of them clear? I did not understand the question. So can you repeat your question? You can unmute and speak if possible, or type the question fully. I can understand. Okay. I think this is the good discussion we had. I think Asia, what is your response on feedback? I think you first time joined these sessions. Do you think it's helpful? Or you can type your response if you can't speak up. Is it clear? Himanshu, you can okay. How to write a program to reorder a queue in C? Reorder. Yeah. Thank you, Asia. I saw your response. So, how to write a program to reorder a queue in C? Reorder a queue. What is meant by reorder? So, reorder is it like a so we need to understand what is the reorder. Okay, I'm first to this session, joined late as I'm unaware of the sessions. Yeah. So this is the, please join the same link, same time, every week, 8:30 um, p.m. IST for you in the night time for in people from India. I'm from USA and I'm from Seattle. So yeah, this happens weekly. This happens weekly, and get into the Discord. Here is the Discord group. I just put it the discord.com, and my username as well, Mentor Suresh. I usually create groups of 10 people, and I will post what algorithms we are discussing, and what is the time and date and time and meeting link. It's always the same link and always the same time, by the way. So yeah, so that's the thing. So yeah, so you're saying something. This happens output 5. Okay, if you say input 5 and 5, 4, 3, 2, 1, you need to say 4, 5, 3, 2, 1. 4, 5, 3, 2, 1. On my question, this has to be output for the given input. Can you tell, sir? So, what is meant by 5? How 5 came into that? Like, is it like 1, 2, 3, 4, or 5 rotations? Or I'm trying to understand why you switched 4 and 5 to reorder a queue in C. What kind of reorder is that? Can you unmute and speak, Himanshu? Can you try? First line 5 denotes the size of the queue. Okay, first line 5. Okay, I have mic problems, sir. Okay, that's fine. So you said the first line denotes the size of the queue. Okay, 5 elements are there, and 5, 4, 3, 2, 1 is given, and 4, 5, 2, 3, 1. So is that like just a one swap? You just need to swap the first two elements. Is that the, so what is the, like, what is the relation between input and output? What swap you're doing, or the rotation? Okay, 5, 4, 3, 2, 1 in the queue elements. Yes. Okay. Okay. So what is the other input? Like how many times you swap? Then 4, 5, 3, 2, 1 reorder queue. So you just need to swap first two elements, right? So I can try to explain that. Let's see. So here is the whiteboard I use. So let's say we have 5. Okay, let's see. We have 5, 4, 3, 2, 1, right? So this is the queue, and here is the front of the queue, and here is the rear of the queue, and here is 5, 4, 3, 2, 1. The reorder queue must be in a format so that the first two elements are taken into account, in which the greatest among them will be swapped to the higher order, followed by the next two elements, and so on. Did you understand, sir? I'm unable to get output for this code. Okay, so I'm trying to understand the algorithm here. So reorder the queue must be in a format so that the first two elements are taken into account, in which the greatest among them will be swapped to the higher order, followed by next two elements. Okay, okay. Oh, it's like 4, 5, 2, 3, 1. Okay, got it. Basically, you're swapping two elements at a time. So you are considering. So this is what I understood from the given context. So you need to. Yeah, go ahead, Himanshu. You said we need to take two elements at a time. Yeah. Yes. Yes. I see. So very good. So what we need to do is two elements. You need to consider two elements at a time and then swap it. Since it is, so it's always like a small element, and then big element, right? big element. Let's say the 5 4, because the 4 is small, it should come here and 5 should go here. Now let's, yeah, so now you need to 3 and 2, again the small element 2 comes here and 3 comes here. So let's say if the 2 is here and 3 is here, we should not modify, right? Because it's already following that pattern. 2 comes here, 3 comes here, isn't it? We should not swap, correct? Because it's already in a higher order. Exactly. So we did similar kind of thing. What we need to do is, um, first of all, this is a similar algorithm. Of course, we what we did is similar algorithm is like swapping elements. Let's say you have a big linked list, and if I say swap k elements, then every k equal to 2. Let's say if k is equal to 2, these two will be swapped, these two will be swapped, these two will be swapped. So we already practiced that algorithm. So but here is just like blindly, instead of blindly swapping, we're just adding one condition. Okay, that's the difference here. What we need to do is we always create a separate function. Okay, that function will take these two elements. Okay, let's say element e1 and element e2. So you just compare these two values, and in addition to these two values, you also need to have the kind of before element and after element, right? Because because you need to have this in order to, let's say, you need to swap e1 and e2. Okay, how do you swap? How do you swap e2? Let's say this e2 is, this is e1, let's say this is e1 and this is e2. So the swapping of e2 comes here. That means whatever the before element, that needs to point to this e2, isn't it? That's the before element. You need to have that in your hand. You need to have the, what is the before element. If it could be it could be head. If there is no elements, if this is the first e1 is first one, right? 5 is first one. In that case, before element is a head. So head needs to point to the e2, and then e2 points to e1, and e1 needs to point to the next element in the queue, which is like e2 dot next. You may not need the after element. So what you need to do is e1 points to whatever the next element, e2 dot next. So that's how you need to manage the pointers. It's just a management of pointers than anything. Okay, so let me show you that algorithm. You can definitely understand based on that. Oh, my OneNote crashed, and let me open my OneNote. It's just a slight modification to the algorithm that we discussed in the past. So I can send that link as well. So here is the algorithm. Yeah, reverse every k elements. Okay, reverse the entire list, reverse the pairs, and reverse the group of k elements. So this one has all the code. Okay, Aditya is here again. Tarun is still here. Good. Yeah, let's look at this. It's still loading. Okay, so this one is reverse pairs. So what I did here is, it is still loading, right? Okay, so here is the node class, and here is the add node, and this is very common here. And then printing, this is the printing class, and here is the reverse pair. This is the reverse pair. Okay, this is how to do this reverse pair. First node and previous node, as I said, like first node and previous node, whatever the previous node and then whatever the first node. So if the first node is null, return null. If the first node dot next is null, return the first node. So let's say you have some nodes. Okay, first node, second node equal to first node dot next, and third node equal to second node dot next. So very carefully understand here how to reverse. Of course, in your case, right, you need to compare first node value and second node value. So what I'm trying to say here is, we got three things. previous, then I'm saying before node, it's like previous, okay, prev, and first node. We got these two elements into the algorithm, into that method. We know by using first node you can get the second node. First node dot next becomes second node, right? Sn. Now you got first node and second node, you can compare the values, right? If the first node is bigger than second node, then you have to swap, otherwise you don't need to swap. So the algorithm continues only if it satisfies this condition. Let's say if it satisfies this condition, yeah, see that e1 is greater than e2, 5 and 4. Now what we need to do is previous node, like, and we also need to know third node. What is the third node? Th or tn. Third node is the number 2 here, right? That is what we are taking. If I go back here, we took the second node, we also taking the third node into account. Now second node dot next equal to first node. What is meant by this? Second node means second node dot next, this is the second node. Second node dot next equal to first node. So I am connecting 4. Let me take another color. I am connecting, let me take black. Second node 4 dot next equal to first node. Okay, now first node dot next equal to third node. What is first node? First node is 4, 5 here. 5 dot next equal to third node. What is third node? Third node is 2, right? So first node dot next equal to third node. 5 connected to 2. Are you following so far? We are changing the connections. Okay, this is what will happen. So this is all happens in a 2 lines. Okay, so second node dot next equal to 5. First 5 dot next equal to third node, which is number 2. Okay, now let's look at the if condition here. If previous not equal to null, that means there is some element before this first node, previous node is there, then previous dot next equal to second node. That means, let's say in this situation previous node is head, because head points to first node, right? Whenever you start the initialize, head pointed to 5, that head, now that becomes previous node. So head dot next equal to second node, which is 4. So now head pointed to second node. Now what happens? 4 4 connected to 5, 5 connected to 2. So you finally swapped these two elements, isn't it? Himanshu, did you understood so far? So yeah, I will share the code, but that's the condition. So basically this is just blindly reversing the pairs. So instead of blindly reversing the pairs, you just need to add one more condition after 108. After line number 108, you need to compare the values of the first node and values of the second node. If the first node is bigger, then proceed. If the first node value is small, you just return the algorithm. Okay. So that is the, what's that? Can you should we add anything in that, in this? No, it's not the same code. It is blindly reversing the pairs, as I just said, right? So I'm not comparing the values. Your question is little bit changed. You said we have to change, we have to reverse, or we have to exchange the elements only if it satisfies that condition, right? So add that condition after line number 108. If the first node value is bigger than second node value, then only proceed. Otherwise, just return. Okay, that's how it is. So how to do this? This is the using additional data structure. So this is just an algorithm where it will take two nodes in two nodes, first node and previous node, and does this. But you have to run this algorithm for every pair, right? This is just a core logic here. But what about the actual algorithm? This is the actual algorithm where it starts with the reverse node with k equal to 2 in this situation, and we are taking a stack in order to do this, and then current node, and then current node not equal to null. We are running with each node, terminate the loop whichever comes first. So current node not equal to null or k count less than k. So we are pushing it. We are pushing the nodes. And then where is the reverse pair? Wait, I think this is a different algorithm. Approach one additional data structure. Maybe I'm not calling. This is a different way of doing it. Let me collapse this. So reverse recursive is also there. This is a reverse pair. I think these are the different algorithms. Okay, reverse nodes. This is similar algorithm but using a stack data structure. Okay, and reverse nodes with using a recursive method using without using additional data structure. This is also different. Okay, I think what we need is reverse node. Where this one is used, we just need to find out. Okay, here is the thing. Reverse node, reverse linked list in a group of 3. So if I go here, reverse nodes, right? So what will happen? Reverse nodes. Okay. Okay, so here reverse pair, where is that reverse pair was used? I'm trying to find reverse pairs. Reverse pair was used here. Yeah, reverse pairs. So this is the main algorithm, right? So here is we have 1 2 3 4 5 becomes 2 1 4 3 5. It's exactly like what you assumed, right? Only thing is we are blindly reversing the nodes. 1 2 becomes 2 1, 4 5 becomes 4 like 3 4 becomes 4 3, right? So how to do this? I took a head here and the previous node is null because for head previous node is null and head 2 equal to null. Okay, now n not equal to null, n dot next not equal to null. This is the while loop and here is the reverse pair. I am passing the n value. N is first initialized with head. Okay, and also passing the previous node. And if head 2 is null, that means you first executed this function and then head 2 is null, then head 2 becomes n. Okay, and then if n dot next not equal to null, right, n dot next not equal to null, then previous equal to n dot next, and then next equal to next dot next dot next. Okay, somehow I was muted actually. Can you hear me now? Yeah, so basically this reverse list pair is the actual algorithm that calls the reverse pair. Okay, here is two things. What we are doing is we are taking two nodes at a time. So n is the first node and previous is the null. And then first node means 1 and 2 will be taken care, and then n will give you the second node. The return of this node is basically number 2. N becomes 2, so that is head 2 equal to 2. Okay, now what we do is if n dot next not equal to null, that means after 2 there are some elements. If there are some elements, then what we need to do is basically we need to make sure previous equal to n dot next. Now previous becomes 2, not 2 actually, previous becomes 1, and then n equal to n dot next. That means this becomes 3. So what I'm trying to say here is you're done with 4 and 5. Here let's say we have this 1 2 1 2 3 4 5, right? You done with these two nodes. You made 2 here and you made 1 here. Now this is n dot next so the 1 is connected with 3 and 4 and 5. Is n dot next is null? No, it's not null. Now what we need to do is this will become previous. This no no this will become previous. This will become previous, and this will become n. That's what we do here. Previous equal to n dot next. Oh, wait. And okay. N dot next equal null. Okay. N dot next. Okay. I think n becomes 2. This is n. So let me see what we are returning from this. So if I go to this method again, so what are we returning? We are returning the second node. Okay. What is second node? Second node, third node equal to second node dot next, and second node dot next equal to first node, and first node dot next equal to third node, and then previous, and then finally we are returning the second node. Okay. Second node is, where is this? Okay. Second node is basically, in our case, let's say 1 2, right? So second node is this one 2. This is n basically. Okay. Now we are checking n dot next. Okay. N dot next is still 3. So that's why we call this will become 2. The previous will be set to 1. This is the previous, this is the previous, and this is the n. So now you swap 3 and 4 using the previous becomes 1, and then you continue. So basically now these two will be swapped. Okay. That's how it is. Look at the algorithm. I take the values and run the algorithm and put the breakpoints, and then you will definitely understand. Okay. So let me share this with you. This will give you basic idea how to solve the problem. Yeah, I can send this code. You just need to modify a little bit based on your requirement. Okay. Cool. I will also record this session, and I hope it will be helpful. And please join next week at the same time, like 8:30 p.m. IST. And where are you from, Himanshu? You can speak up. You can unmute. From Hyderabad only. Okay, very good. So how did you find this meeting link? Where did you find this? DSA group. Very good. In the Discord. You mean in the Discord? Oh, in WhatsApp. Okay, very good. Yeah, please join and ask other people to join. So I got some requests from. Yeah, join the Discord as well. I got Yeah, I got Aditya. You added, and I will add to one of these groups. We can definitely discuss. Okay. I hope this is helpful. Yeah, discord.com, and here is my user ID, Mentor Suresh. So just go to discord.com. Okay. There is a big SD groups channel. There are a lot of people. SD Skills Discord. You can also sign up for SD Discord. It will be very helpful for people who are preparing for interviews. Okay. Done first year BTech. What's that? Very good. You just completed. Very good. Very good. Very good. Very good. So you are at the right time, because by the time you finish your BTech, you will be super awesome and great and proficient in algorithms. That will be good. And get your. I will cover mostly the DFS logic and DFS algorithms. Yeah, invite your friends as well. So my expectation is people should have basic understanding of loops, all these things. And I basically cover algorithms from these books: Cracking the Coding Interview, Lead Code, Geek for Gigs. My point here is to give a direct sessions and solving the problems and explain questions, anything. We have tons of YouTube videos, but the problem is you may not be able to follow, right? So if you are watching YouTube, you will do. Very good, very good. Yeah. So very good. So I cover algorithms from arrays, matrix, strings, linked list, trees, graphs, sorting algorithms, dynamic programming, greedy algorithms. The problem here is, like, many people complete their degrees, but they may not aware of these problems, or they forget while interviewing, like after 3 4 years, like you may not be able to remember all these algorithms, and practice also won't be there. So so that's why, like, people who studied, who practiced while they're doing MS or BTech, they will be able to succeed easily. The people who don't practice while studying, they will struggle while attending interviews. Okay, it's very good practicing while studying itself. So I spend 1 to 1.5 hour a week, and I will try to cover these concepts. So I will slowly going, like, my concept is not like a quantity, like I want. It's not like something like a scheduled, like a crash course or anything. I'm going with one by one, and make sure, even if I explain one algorithm, you have to understand 100%. That's my goal. If you understand 100%, that I will be satisfied, right? So, and I will explain the time complexities and all. So we haven't discussed about time complexity in our algorithm. So in our Q algorithm, type anyone can share time complexity. We discussed first algorithm, which is like implementing Q using a linked list. Aditya, I think you are there since beginning. Can you tell me the time complexity for this one?
NQ.
Yeah, implementing Q with linked list. NQ, what is the complexity of NQ and what is the complexity of DQ?
If you're having rear and front pointers, then I think it will be big of one.
Exactly, exactly. Very good, very good. Yeah, because we are not navigating
And
the
if we
elements
are
like
having only one,
exactly. It's a
yeah.
it's a constant operation. Very good. So Himanshu, did you understand that thing concept? Why it is order of one? Very good. That's good. That's good. So in case of this one, right, the algorithm we just discussed, the pairs, reverse pairs. Anyone can tell what is the complexity? O of n. Yeah. So of course we are swapping these two elements, but still it's O of n. It's not like little bit. Yeah, it's a little bit more than O of n, but still you can consider O of n, because we are not navigating like n square or anything, right? We are only like taking each element and checking with the next element and swapping again, taking each element. It's a linear in time. Yeah. So that's good. Yeah. So these are the good discussions. I want to make sure you understand the algorithm, you understand the coding practice, and also understand the concepts of space and time complexity. Okay. Yeah, yeah. Please, if you have any questions, the only thing is like the time commitment is very good. And what are the concepts? You have all these concept trees, graphs, everything. Wow, very good. Very But did you cover algorithms like I don't know? Very good, very good. Yeah, I practiced around 10 types of sorting algorithms, and yeah, I will send those as well. So no issues. So yeah, did you cover any of these algorithms in your trees, like in the trees class? Yeah, that's just a concepts, right? How about have you covered anything like pre-order, in order? I think that you covered those, right? And BFS. Okay, okay, yeah. Practice those, very important. Like like level wise sort and BFS, BST, finding an element. Very good. Very good. Very good. Very good. Very good. So I think that's the main thing. Like, yeah, yeah, practice more and make sure you understand the concept. I practiced very like when I'm studying in my classes. Like I did my MSc in 2003, so like around 20 years back. I practiced a little bit, but I have to reverse. I have to revise again. So those trees, I practiced only like binary trees and I think heap tree. Heap is important. I don't think the interviews go that like AVL trees and all those are concepts only. But from the interview perspective, they may not go that deep. Okay, so that's where from DSA point of view, most of the companies will ask on arrays and strings and linked lists. Most companies, okay, and hash tables. But the companies like Google, Facebook, they may go to trees, graphs, okay, because they want people who have deep understanding of these concepts, like Facebook, Google, Amazon. Definitely, definitely. They don't simply say, "Hey, implement AVL tree or something." They never say that. So there will be practical. There are practical questions on those, and you have to use in order to solve those kind of practical questions. You must use AVL tree. You must use some kind of tree to solve the problem. You need to find out, and you need to say in the interview. Say, "Hey, this is kind of let's say you want to create some practical questions, and then you need to apply particular um, tree or method to solve the problem that you have to explain in the interview." Sure, sure, yeah, yeah. So sometime like in the graphs, basically, if I go to the graphs, like I detect a cycle in the graph, do you have this? Do you have this book, the cracking? Do you have the the cracking the coding interview? Very good. This is a must-have book. It's like the Bhagavad Gita for for people who are practicing interviews. It's without this, it's not even possible. I would say. What's that? Yeah, I just sent the link there. Yeah, very important. This covers a lot of questions in interview, and this you see that 189 programming questions and solutions. So it's very somewhere I don't know, a couple of hundreds in India. I don't know, so you can check. So it's around 31. Yeah, you can convert, and if you go to Amazon.in, you can find it. Cracking the coding interview. Yeah, yeah, it's very important. And go through the questions. It has all major questions to cover. Okay, great. So the main motto of my sessions is to give live sessions and make sure clearing the questions, because people may not have full understanding of these concepts. Let's say people who did not come from computer background. You are doing computer degree and you understood this, but what about mechanical or other background? They may not have the full knowledge of these, and it is really tough for them to, very difficult. If they need to learn on their own, it is really challenging, and it's not easy, right? That is the community. That's what I want to help the people who are struggling in those areas. And you also come up with, and you can also explain, because it's a sharing session. It's not always me. You can also, Himanshu, you can say, "Hey, I'm going to explain this algorithm today. Please come forward." Helpful for your interview as well. It will be helpful for you to explain in the interview. So I want to help such kind of people who don't have full computer background and struggling to understand these questions, because we have tons of blogs, tons of websites, and a lot of videos. But the problem is persistence and patience. Like if people watch the videos, but they will get distracted, right? If it is a class, if it is interactive, people will attend to, and they will feel connected. Yeah, that's the main motto. I can create YouTube videos, but what is the point? The thousands of people are already doing, and they are doing better than me. So I don't have that camera skills or YouTube skills, and I don't have time to editing skills. So that's why I'm just doing live. Even if I can help one person, I'm okay. So even if I even one person join, I'm oh yeah, very good, very good. Yeah, go ahead. Yeah. So you're asking about my number, but I would say I will connect with Discord only. So my number and WhatsApp is only for my personal use. For any kind of professional, I have Discord in my phone. I have Discord here always, so you can connect me through Discord. Okay, cool. Then I think it's almost like 2 hours. We already discussed. I think I'm going to stop recording. And please bring your friends as well. This is like if more people are there, I will be so energetic.